Hi everybody. I just wanted to give you a brief rundown of how to do finite state machines with relative ease and try and do them quickly. So what we're going to do here is we're going to start off with a rather longer finite state machine, and we're going to do a minimization with an implication chart. And for our present state, we'll do A through H. A, B, C, D, E, F, G, and H. For our next state, we'll have x equals 0 and x equals 1. And we'll use ACE, BCE, and then E and A. Then we'll do FDB, ADB, A and C. For our outputs, we'll have 0, 1, 1, 0, 1, 1, 0, 1, 1, 0, 1, 1, 0, 1, 0, 1. For our implication chart, we'll start with B and end with H. Then we'll start with A and end with G. Then we'll build a lower triangular matrix. Then we'll eliminate all those squares which have different outputs. So A is not going to be equal to B or C. It's also not going to be equal to E or F. It might be equal to G or H. The outputs are the same. We don't know. Let's see, we did A. How about B? B is not going to be equal to C, D. B might be equal to E. We don't know. It won't be equal to F, G, or H. C is not going to be equal to D, E, G, or H. We're getting rid of a lot here. D, we're up to D now, is not going to be equal to E or F. E is not going to be equal to F, A, G, or H. F is not going to be equal to G or H. G might be equal to H. And so that's what we have so far for trivial reductions. Let's take a look at AD. A will be equal to D if A equals B, but we know it doesn't, so it gets an X right away. A will be equal to G if A is equal to E, but we know it doesn't, so it gets an X right away. A will be equal to H if A equals A. Well, it does do that. And if C equals F. And we don't know about C and F. So let's look up CF. Well, C will be equal to F if E equals E. Well, it does do that. And if B equals B. So C does equal F. C equals F, or is equivalent. A is equivalent to H. So we got a couple of equivalencies already. That's pretty good. Let's take a look at B and E. B equals E. If C equals C, that's promising. And if D equals D. So indeed, B equals E. Well, what about D and G? If we look at D and G, we have B and E. B and E are equal. We already have that. And also we look at A and A. Yes, A and A are equal. So it looks like D equals G. That's pretty good. We got a lot of reductions here. We've already removed 1, 2, 3, 4 rows. Let's look at D and H. D is equal to H if A equals B, but it doesn't. G equals H. G is equal to H if A is equal to E. A does not equal E, therefore we remove it. And so what we have is a nice way to do these things very quickly by hunting for the low-hanging fruit, finding out all the things we can eliminate first, and then chasing down all of the relations that look like they may be appropriate. That gives us a nice, fast way to execute the implication chart. Thank you.